Welcome to today's lesson on graphing absolute value functions. Today we're going to do the assignment and the video together. So let's work these problems. I would suggest once you get the hang of it, you stop the video, try working the problems, and then start the video and check your answers with my answers. Okay, let's do number one. So for every absolute value function, we're going to graph the parent function first. And watch how we take out the 2 and just leave that on the side. So normally, if we were graphing this, we would take the 2 and say, okay, we're going to move it left 2. Okay, so I'm going to save that for later, and I'm only going to graph y equals the absolute value of x. Now, as we're graphing throughout the semester, we're actually going to graph all the specific points. We're going to do about 3 to 4 points depending on the type of graph that we're using. So in this case, we're going to graph 3 points. Let's do -1, 0, and 1. The reason why I'm doing these is because, one, they're easy numbers to graph, and they're in the middle of the coordinate plane, and what I want to do is graph what's in the middle and then shift everything left 2. So there's no reason for me to graph every single number. Since I took out the 2 and I know that I'm going to graph everything left 2, I can simply just do the center of the graph at this point. So if I take a -1 and put it into the absolute value, so I'm going to just plug everything into x, then I get 1. If you put 0 in the absolute value, you're going to get 0. And if I put 1, I get 1. Okay? So now I'm going to go graph those points. -1, 1, 0, 0, and 1, 1. Now what if I wanted to graph some more points? I just want you to think about what numbers you would choose. Okay, just thinking about it, let's see here. In some graphs, you'd want to choose a number that maybe could square root, the number that could square or cube nicely. Okay, so in other words, I'm going to pick numbers that'll work for this particular equation. Okay, and if you wanted to pick some more numbers, you could pick whatever you wanted to. Since this graph is going forever in both directions, both left and right, then I can pick any number on the x-axis. Okay, so I could even do, let's just do 3. So I might pick 3 and -3, which if I plug those in, I would get 3 and +3 again. Okay, so okay, and then I can just draw my graph. Now this is the parent function. All right, I still know I need to move it left 2. So let's go do that. I'll take those lines off and I'll move everything left 2. Okay. And then I'll draw the graph. So by leaving the translation to later, I can now go to each question that we're going to do today. Every single time we graph, we're going to graph the parent. So guess what? I'm going to graph these same numbers. Okay. Now you only have to graph 3. So in this case, for the rest of the questions, I'm going to graph -1, 0, and 1 every single time. Okay. So these are the numbers that I'm going to plug in every time. All right, but because I have taken out the translation right here, I know that, okay, I can use the same numbers every time and then just do the translation at the end. Okay, so let's try number 2. So you can probably do this one on your own. Go ahead and stop the video, but I'm going to work it out for you too. This is the same type of problem where we're going to take out the translation and just plug in -1, 0, 1. So what I like to do is say, okay, in the end, I'm going to move it right 3 and then up 4. Okay. So I plugged in my -1, 0, 1, and I know that when I plug that into what's left, I get 1, 0, and 1, which are the positives because absolute value means make everything positive, since we want to know exactly how many units everything is, not negatives. Okay, so I'm going to go -1, 0, 1. And 0 and 1, 0, 1. Sorry, I did that backwards, but those are all right points. Okay. All right. So now I can graph my equation, but I'm going to move it first. So I'm going to go right 3 and up 4. Okay, so also notice that right now I haven't changed the size or the width of the absolute value. So every single time from 0, 0, I'm going right 1, up 1. Okay, so notice from 0, 0 to here, I'm going right 1, up 1. And from 0, 0 to here, I'm going left 1, up 1. Oh, excuse me, I said that backwards. This one right here was left 1, up 1, and this one was right 1, up 1. Okay. All right. So what's happening is it's the same size every time. So every time I shift my graphs, what makes it great is the fact that I can double check myself and make sure that I've gone right 1, up 1, or left 1, up 1. Okay. So now everything's shifted correctly and I can just draw my graph. Okay, let's try the next problem. So this is the same type of problem. Go ahead and stop the video and try this one on your own. Okay, again, I'm going to take out the 5. I know that in the end, I'm going to go up 5. So I am still going to use my absolute value, and I'm going to put in -1, which is 1, 0 is 0, and 1 is 1. Okay, so I can go plug those. Now, as I'm doing this, and I know I have to move up 5, you don't have to graph the parent function every time. So if you want to just go, oh, I'm going -1, but instead I'm going to go up 5 for every single one. So what I'm going to do is I'm going to go 1, 2, 3, 4, 5, because I'm going to shift everything up 5, right? Which means I'm going up to 6, And then at 0, 0, I'm going to move up 5. Okay, and that's actually my new function. So it's okay to shift as you're plotting the parent if you wish to do that. Okay, if the parent is not drawn on the graph, that is okay. All right, let's try the next one. Okay, so now we're getting into a different kind of graph. In this graph, there is no translation. So I'm not moving left to right, and it's not moving up or down. But there is another number in the graph. So we're going to go ahead and calculate what this number would be. I'm going to go ahead and use 2. Okay. Now notice that I did take out the translation on the previous graphs, but I'm not going to on this one. The 2 is actually the vertical stretch. So what we're going to be doing is we're going to be looking at a parent function that is changing. So it's either going to be skinnier or it might be wider. Okay, so let's put in the same numbers because we know that this graph is still in the center. There is no translation, so I can still use the same numbers if the graph is in the center of the coordinate plane. Okay, so if I put in -1, I'm going to do 2 times absolute value of -1, which the absolute value is 1. 1 times 2 is 2. I'm going to do the same thing for the 0, which ends up being 0. And then the same thing for the 1. Okay, so now I'm not going one, let's see if I go over here and go here. If used to, in the previous problems, what we did was we went over 1, up 1, okay? Now we're going over 1 and up 2. So notice that our graph is getting skinnier, okay? And that's all we have to do because there's no translation. Now, if there was translation, we would go ahead and do that at the end like we were doing with the last one. Okay, but this time we just leave it as is and just show that the graph is now skinnier. Okay, let's try the next one. For number 5, we're going to do this again. We've got translation, so we're going to take out the 2, which means we're going to go right 2. And then we're going to take out the 4, which means we're going to go up 4. Okay, and I'm going to use my same numbers because now I've got a graph that's in the center, and we'll do the translation at the end. Okay, now I also have another number that's sitting in here that I can't quite see right now, because this is really -1. This negative right here is a -1 in front of the absolute value of x. So what I'm going to do is I'm going to plug in my -1 right here, okay? And let's see what we get. So if we do -1 absolute value of 1, we're going to get a -1. If we plug in 0, we're going to get 0. And again, if we plug in, there we go. If we plug in -1, right, 1 into the absolute value, then we get -1. Okay, so we're going to do -1. Now this time, the instead of our previous problem where the graph is getting skinnier, this time the graph's not necessarily getting skinnier, but we're not going to the right, moving right 1, up 1. What we're going to do is we're going to move over 1, down 1. So that negative in front means that the graph has been reflected over the x-axis, which also you can think of as being flipped upside down, okay? But this is called reflection over the x-axis. And there's my new graph. Okay, now I do still need to move it to the right 2 and up 4. So I'm going to do the exact same thing. I'm going to move everything right 2 and up 4. I know it's right 1 over 1. I know where they are here. I just need to move each of these points right 2 up 4. Okay. Same thing, still upside down, and then just draw my graph. Okay. All right, so that's it for this set of problems. Let's try the next problem that includes the inequality. So in this problem, we're going to do the same thing. We're going to put in a -1, 0, 1, and I'm going to do the translation later. So that means I'm going to go left 3 after I finish graphing. Okay, so I'm going to put in -1, and remember I'm just doing the absolute value of x, and we'll do the inequality at the end as well. So if I put in -1, I get 1. And if I put in 0, I've got 0. If I put in 1, I get 1. Okay, so -1, 1, 0, 0, and 1. Okay, now I need to go left 3. So we'll do left 3 right there. Oops. Okay, now I can go ahead and graph or draw my new graph. Okay, but I need to shade it this time. All right, so what I'm going to do is if it's less than, I'm going to shade on the bottom. Okay, we're going to test this in just a second. And if it's greater than, I'm going to shade on the top of the graph. Now, if you probably use that rule as well with linear equations, okay? But let's test this real quick. So let's see here. Let's go with testing a point that is not currently on the graph. So let's test an easy point. Let's test 0, 0 right here. So 0, 0 is not on the graph. Okay, so we're going to put 0 in for y. Put 0 in for y, and then 0 in for x. And we're going to get 0 is less than or equal to 0 plus 3, absolute value of 3 is just 3. Is that a true statement? 0 is less than or equal to 3? Yes, it is. So therefore, I know that all the points that are sitting below this graph are going to be true. So we shade everything below this graph. Okay? All right, and that would include if I wanted to extend the graph all the way up like this. If I extended the graph up, then it would be everything below it like that. Okay? All right, so let's try the next problem. Okay, So we're going to do the same thing that we've done before. And this one you can probably do on your own, and then stop the video and then check out how I work it and confirm that you got the right answer. Okay, again, I'm going to take out this -7. I'm going to move it to the right 7 at the end, and I'm going to move it up 1 at the end. Okay, so all I'm graphing right now is the absolute value. Okay, and then I'll do the inequality at the end as well. -1, 1, 0, 1. Notice that I get to use the same numbers every time just by being smarter than the graph, right? If we know how the graph is going to work, then we don't have to do something different every single time. Okay, so then after I've graphed, I'm going to move to the right 7 and up 1. My up 1 in there. Okay, right 7, up 1 for every single one of them. And then I can go ahead and draw my graph. Okay. All right. Now I need to do greater than. Remember that I said a greater than means you shade on the top. Okay. Less than means you shade on the bottom. Okay. So if I'm doing a greater than, then what I need to do is let's test it real quick just to make sure. Okay, now once you get used to this, you don't have to test it every single time, but I'm doing that for your benefit so that you can see what I'm talking about. And again, I'm going to do 0, 0, okay, because 0, 0 is the easiest one. This point right there is the point I'm going to test. So I'm going to put 0 in for y, and I'm going to put 0 in for x plus 1. Now 0 greater than or equal to, this is going to be a -7, and -7, the absolute value of -7 is a +7, and then I'm going to add 1, so that's going to be 8, and that is not a true statement. Okay, so if that's not true, if I'm not supposed to shade here, then where am I supposed to shade? Well, it says if it's greater than, shade on the top. Which shading on the top, if it's a open V that's faced up like this, means I'm going to shade on the inside right here. Okay? All right, let's try the next one because we need to see some that are reflected and across the x-axis so we can see where those shade. Okay, so for our next problem, we have a couple of things going on here. Okay, we're still doing a greater than. We have a number up in front, which means that this absolute value is going to be a little bit wider, and then we have that we're going to shift. So this is going to be right 5 and up 3. Okay, now notice that I am just scratching out the numbers. You don't have to do that. That's just for your benefit so that you can see how the thought process that's going on here, because I'm only using the base equation. I'm using the equation that will be in the center of the graph. Okay, so I'm going to notice that I'm doing an equals right now because I'm going to do the shading later. So I'm going to do the greater than at the end. Okay, now also notice that I've got a 1/2 in front. That means that I'm going to have to graph a 1/2 for each one of these, right? And that's going to be really tight right there. Let's try a different number. So sometimes, even though I'm in the center of the graph, okay, let's do that like that. Sometimes it's nice to be able to change these numbers. So let's change this number right here. Be a little bit smart with the numbers that we pick. it doesn't really matter which numbers we pick, okay? So what I'm going to do is I'm going to pick -2, 0, and 2, okay? Because when I put in a -2 into the absolute value, I get +2, right? But 1/2 times +2 is really just 1, okay? 1/2 times 0 is still just 0. And 1/2 times the absolute value of 2 is just 1 again. So now what I have here is -2, 1, 0, 0 again, and 2, 1. Notice my absolute value is wider. Okay, done. Now all I have to do is shift it right 5 and up 3. Okay. So right 5 up 3 would be right here. I'll be honest, when I do this, I do all of them right 5 up 3, but I also look to see, look, this is right 2 up 1. So I just verify right 2 up 1, and then, or left 2 up 1, and then I know I've got it. So I'm doing both at the same time. Okay. All right, so now we have our new graph. Yes, it is wider. And I need a graph a greater than, and since there's no equal to, I need to make these dashed lines, okay? And on top of that, I need a graph on top of it, because if I go in and plug 0, 0, so let's try 0, 0. If I plug in 0, 0, 0 greater than 1/2 0 minus 5 plus 3. Okay, so -5, the absolute value of -5 is 5. 5 divided by 2 is 2.5. And 2.5 plus 3 is going to be 5.5. And that is not a true statement. Okay, so I know that I'm going to graph above. And as we do this, let's just start saying, okay, if it's greater than, you graph above, and if it's less than, you graph below. All right, so that included the 1/2 making it wider, which we haven't seen yet, and it also included a greater than that was not an equal to, so we had to dash. Okay, let's try this again. Okay, so we're almost done, and this time we're going to graph a absolute value that is going to be reflected across the x-axis. We're going to do the same thing as we've done before. We're going to take out the translation. Okay, so this is going to be right 6. Okay, and I'm still going to get, I'm going to do -1 absolute value of x. Notice we have a -1 sitting in front here. So if I put in a -1, that's going to give me a -1. Put in a 0, that'll be 0. And if I put in a 1, that's still going to give me -1. Remember that we take the absolute value, but then we multiply by -1. Okay? All right, so then I plot my -1, -1, 0, 0, and 1, -1. Okay, it's upside down, but what I'm going to do is I'm going to shift everything to the right, 6, right there. Okay, and then I can go ahead and graph that one. Now, go with the same rule. If it's less than, you graph on the, you shade, excuse me, on the bottom. And if it's greater than, you shade on the top. Okay, in this case, it is less than. So we're going to shade on the bottom. But the bottom for a graph that has been flipped upside down like this, or called reflected across the x-axis, the bottom's going to be right here. Okay, and we can check that by plugging in 0, 0 like we've done before. 0 is less than negative absolute value of 0 minus 6. Okay, so 0 is less than negative 6 is an absolute value, but it still makes negative 6 because of that negative in the front. So negative 6. This is not a true statement. 0 is not less than negative 6. So we know that we're not supposed to be shading on the outside right here. Therefore, we know we're right. Okay? All right, one more time. Okay, we're going to do the same type of graph again, where we're shifting it and it's going to be upside down. Let's plug in negative 1, 0, 1. And we're going to do equals negative absolute value of x. So that means that when I plug in negative 1, it does become positive, but that negative 1 on the outside makes it a negative 1 again. And this one's going to be a negative 1 as well. Okay, remember that I'm going to shift this left 4 at the end and down 2. Okay, all right, so the only thing I'm dealing with is the negative 1 with the absolute value of x. Okay, now, so let's go ahead and graph this. We're going to do 0, 0. Okay, and then I'm going to shift it, left 4, down 2. Okay, and I shifted all the points left 4, down 2, and now I just have to shade. Okay, this graph is a greater than, which means I shade on the top. So on the top of a graph that has been reflected across the x-axis, meaning that it's upside down, on the top means that I shade above the graph. Okay, I can even check 0, 0 to make sure that it's working. So 0 greater than or equal to negative 0 plus 4 minus 2. So I'm going to say 0 is greater than or equal to negative 4, positive 4 on the absolute value plus a negative, add that negative to it, makes it a negative 4, so that's a negative 6. Okay, and is that a true statement? Yes. Okay, well that's it for today's video. Please make sure that you understood how to graph these. Check to see if you could do them on your own. And then let's ask questions in class or send me an email if you have any questions. Okay, and thanks for watching.